Hi, my name is Eloise. Welcome to another lesson in the series on investigating geometry. If you've been following this series, then you probably know Gerard and Cindy, who've joined us in our investigations. Hi guys!
Hello.
Hi everybody.
Can you remember what we've covered so far in the series?
Let me see. We made conjectures about quadrilaterals and we went on to prove or disprove them.
Yeah, and we use different ways of writing down the proofs.
But don't forget, so far we've only used two kinds of geometry: transformation and Euclidean geometry. Today we're going to look at how coordinate geometry can be used to investigate the properties of polygons. By the end of this lesson, you should be able to use coordinate geometry to identify the properties of a shape. So let's start off by reminding you that in coordinate geometry, we work with points, lines, and shapes on the Cartesian plane. Then there are 5 tools that we're going to find very useful.
I think I know what tools you're talking about. One is a way to work out the distance between 2 points.
Then there's a way to work out the gradient as well as the midpoint of a line segment.
And we might need to use what we know about the parallel and perpendicular lines.
That was very well remembered. But do you remember the formula that goes with each one?
No, not really.
Well, we can work out the distance between 2 points by using this formula. The square root of x2 minus x1 squared plus y2 minus y1 squared. We can find the gradient of a line on the Cartesian plane by using this formula. Change in y over change in x. Next, the midpoint of a line segment. Remember that the midpoint is found by working out the averages of the coordinates of the 2 endpoints. So you add the 2 x values and halve it to get the x value of the midpoint. Then you add the 2 y values and halve that for the y value of the midpoint. Also remember that parallel lines have the same gradient. And if you multiply the gradients of the perpendicular lines, the product should be -1. These are the 5 formulae we are going to use. These 5 facts and formulae are used fairly often when proving conjectures with coordinate geometry. Now we're ready to see how they can help us with investigating polygons. Right, are you ready to solve a geometry problem?
I'm ready.
Sure.
Here's a triangle on a Cartesian plane. And here's the question. What kind of triangle is this? Use coordinate geometry to prove your answer.
I reckon they want us to do something to prove whether the triangle is either isosceles or equilateral.
How do we do that?
Well, an isosceles triangle has 2 equal sides, while an equilateral triangle has all its sides equal.
So you're suggesting that we look at the lengths of all the sides of the triangle and see what we come up with?
Exactly. If we get some equal lengths, then we can decide what triangle we have.
I like the way you're thinking. You've discussed it until you arrived at a method you both agreed on. I've noticed that you didn't write down a plan. This time it's okay because it's an easy plan, but don't forget, planning makes the rest so much easier. Okay, carrying on and keep up the good work.
To work out the lengths of the sides, we need to use the distance formula because we are working out the distance between each of the points. And the distance formula is square root of x2 minus x1 all squared plus y2 minus y1 all squared. So let's work out TR first. Here we substitute into the formula to get -2 minus 0 all squared plus 8 minus 0 all squared. That is the square root of +4 plus 64. That is the square root of 68.
Cindy, I'd just like to quickly point out it isn't necessary to work out the square root of 68 as we're not really interested in the actual length of the side. We only need to check to see if it's the same as the other sides. So what comes next?
We need to work out side TY. So that's the square root of 7 minus -2, which is just +2, and then all squared, plus 6 minus 8 all squared. That's the square root of 81 plus 4. That gives us the square root of 85.
The square root of 68 and the square root of 85, those two are definitely not the same lengths.
But it does tell us something, that our triangle can't be equilateral because already we have two sides that are not equal in length. Okay, now for the last side, YR. Square root of 7 minus 0 squared plus 6 minus 0 squared. That's square root of 49 plus 36, and that is the square root of 85. Great! YR and TY are the same length, so this is an isosceles triangle.
Great stuff, Cindy. You've answered the question. All you did was use the formula for working out the distance between 2 points and compared the answers to see if there are any equal lengths. Now, let's move on to something a bit different. Here's the second problem. Use coordinate geometry to prove that this is a rectangle.
A rectangle? Do we just use the distance formula again?
We could do that. If this is a rectangle, then RE and CT should have equal lengths, and EC and TR should also be equal.
Maybe we should check a definition for a rectangle first. That will tell us if we have enough to prove if this shape is really a rectangle.
Good thinking, and we should remember to make a plan. And we've got to find our starting and end points. You know the given and required to prove bits?
We've already seen how much planning helps. So before writing any proof, always make a plan and remember to include your starting point and your end point.
Right, let's write down what we've been given. We've got a quad, RECT, on the Cartesian plane. Now let's look for our end point. We have to prove that RECT is a rectangle.
Okay, to prove that something is a rectangle, we need to show that it has certain properties.
I agree. By our definition, a rectangle is a quadrilateral with all the angles equal to 90 degrees, and the opposite sides are equal, but the adjacent sides are not equal. So to prove that this quad is a rectangle, we've got to show that RE is equal to TC and TR is equal to CE. That will tell us that the opposite sides are equal. Then we must show that TR is not equal to TC. That will show us that the adjacent sides are not equal. Because if they were equal, then it will be a square.
But how do we show that the angle on the shapes are 90 degrees?
You need to work out the product of their gradients. If you get an answer of -1, then they are perpendicular to each other.
So we need to work out the gradient of each line and then show that the product of the gradient of the sides that meet is equal to -1.
So do we have to do this 4 times over for the 4 angles?
No, but we do have to show it for 3 of the angles. Because if those 3 are 90 degrees, then the last one must also be 90 degrees.
And that's it. We will have shown that the opposite sides are equal, the adjacent sides are not equal, and all angles are equal to 90 degrees.
Good work, guys. You're right on track. So far, you've got a good plan. Now let's see how you write out the actual proof.
Okay, so we used the distance formula to find the length of each side. And we found that RE is equal to TC and TR is equal to CE. But the square root of 50 is not equal to the square root of 98. So the adjacent sides are not equal. Then we looked at the gradients. We wrote it as m with the name of the line here each time. You can see that we found the gradient of each line and worked out the product of the gradients. It was -1 each time. So the lines do meet at 90 degrees.
Well done. You've used coordinate geometry to prove that RECT is a rectangle. But your proof is not the only way it could have been done. Let's look at another way of answering this question. We could define a rectangle as a parallelogram that has all the angles equal to 90 degrees. This means that we can find a way to prove that RECT is a parallelogram and then prove its angles are 90 degrees. But to prove it's a parallelogram, we can look at our definition for a parallelogram. So all we have to do is prove that line TR is parallel to CE and TC is parallel to RE. We don't even need to look at the lengths of the sides. All we have to do is show that the gradients of the opposite sides are the same because parallel lines have the same gradient. This is what the finished proof looks like. The gradients of TR and CE are both 1, so they are parallel. And the gradients of TC and RE are both -1, so they are also parallel. Then we can multiply 1 times -1 to get -1. This means that these lines are perpendicular and so are these. So both pairs of sides are parallel and all the angles are 90 degrees, making this a rectangle. So we've seen some interesting things here. Firstly, you used what you know about working out the distance between 2 points and what you know about perpendicular lines from coordinate geometry. But in my proof, I used what we know about parallel and perpendicular lines. Okay, now it's time for you to practice this, so please make sure you copy down this information carefully. Given Q, -3, 6, U, 2, 1, A, -3, -4, D, 8, 1. Use coordinate geometry to identify and prove what properties Q, U, A, D has. Well, that's it for today. We've shown you different ways of proving the properties of shapes using coordinate geometry.